Okay, so write the expression in the quadratic expression in factored form. I mean, this is just magic numbers, right?
Yeah,
So what are my magic numbers?
10 and 6. Except it's going to be
What are the signs going to be?
negative 10.
Plus 10, because I got to get a positive, right? They got to multiply to negative 60 and add to positive 4.
Yeah.
Okay. Let's talk about how we can check these, because you only get one retake, so you got to check everything on this, right? How could I check this? I could, well, there's no value to plug in here, so we're not solving something.
You FOIL it out.
Okay, I could just FOIL it out, could expand it out and see if I get, if when I multiply it out, do I get this? The other thing you can always do, remember, if you're not solving an equation, and this is the best, I think I've talked a lot about this. This is the best SAT trick in the world. Whenever you're trying to simplify or rewrite something or factor, just writing it in a different form, pick a random value of x, plug it in to the first expression, plug it into your answer and see if it kicks out the same number. If it does, the odds are spectacularly high you did it right. Okay? Same thing there. I'll skip that one, right? How about this, though? This is one I kind of want to go through. So if we're going to factor this one, and when you're factoring stuff, kind of go through your mental checklist. What's the first thing you always want to try to do when you're factoring something? Always want to see if you can, say it again? That's second. First, we want to always see if we can, what? Factor out a greatest common factor. If we can undistribute something. Is there something that's going to divide into all those, though? I mean, even just the 8 and the 21, you can see there's nothing shared. The 21 doesn't have any power of x, so we can't take out any variables. So we're stuck with this the way it is, right? We can't factor out a greatest common factor. So now we're stuck with a number in front of x squared. So what's our technique for factoring something where we've got a number in front of x squared where a is not equal to 1? Remember that one? Yeah, we reviewed it this year. You learned it in Algebra 1. What's that called? Well, you could. You actually could use the quadratic formula and get your answers and just. I'll show you that. That's a good point. But there's maybe an easier way to do it. Remember bottoms up, right? If you have something here, if this is not 1, then you gotta go bottoms up, right? With bottoms up, we gotta find magic numbers, but the magic numbers, they have to add or multiply to whatever a times c is. Well, 8 times 21 is 168, and they have to add to b, which is 34. And so we're just going to find those numbers. How are we going to find those numbers? We'll just find factors of 168 until we get some factors of 168 that add up to 34, right? So so we could do 168 times 1. Well, that obviously doesn't work. We could do, if I divide that by 2 and multiply that by 2, I get, what, 84 times 2. That's way too big a sum. 3 goes into that 56 times. Still way too big, right? How do I get the 4? Well, if I multiply this number by 2, don't I have to divide that one by 2? Right? So I get 42 times 4. It's getting closer. 5 doesn't go into 168. 6 goes in 28 times. That's it, isn't it? Right? Because that sum is 34, right? So my magic numbers are 28 and 6, right? So step number 1, right? And if you want to go back, there still is, that sheet, that PDF you can print out if you wanna look at an example, or just Google bottoms up, I mean, if you wanna see another example of that. But I would definitely do this problem on the practice test. You know, go through and do at least one of these till you can do this successfully, because it's guaranteed to be on there at least once. So now that I've got my magic numbers, that's step one, right? Step two is to set up our template just like we normally do, just like we did on this problem there, right? Only it's not the end of the line for this one, right? So step two, we're gonna set up x minus, or x plus, that's positive, x plus 28 times x plus 6. Okay, what's step three? One more step on bottoms up. What do we have to do with that template? Because that clearly doesn't work. If I expand those out, x plus 28 times x plus 6 is not going to equal that, right? What do I have to do? You guys don't remember bottoms up? Yeah, oh good. So whatever's out front, I have to divide both of the fractions by that, right? Reduce the fractions, and if I still have a denominator, it goes bottoms up, right? So then, what does 28 over 8 become? Let's see, 4 goes into both, I think. 7 over 2. Good. And then 6 over 8 reduces to 3 over 4. Okay, so I did get stuck with fractions in both those cases. If I didn't, if that would have just been x plus 3, it's done. But because I've got a 4 on the bottom, I guess the last step, if you even want to call this one a step, is I go bottoms up. Same thing here. The 2 goes bottoms up, and our final answer just looks like 2x plus 7 times 4x plus 3. And once again, how would I check it? Well, just multiply it out. See if you get that, right? Okay. What's the other way of doing this? Well, there is another way. There is another way. You actually could. You could use the quadratic formula and turn your solutions into factors, right? Because solutions and factors go together, right? Remember we always said stuff like, here, let me divide this. So that was bottoms up. That's, I think, the best, quickest way to do it. Here's another way. We always said that if we have a solution like x equals 3, for example, what's the factor that goes with that? Let's get all, I don't want to see, like, phones need to be away. This is a test that can go on your grade that's weighted more strongly than a regular test. So you want to be involved in this. What's the factor that goes with that? X. What factor could I set equal to 0 to get the answer 3? Yeah, it's just x minus 3, right? The factor is just x minus the 0, right? Or the solution, right? So if we could turn this into, if we could find out what the solutions were, or the zeros of that function, we could just turn those into factors, right? Okay, so let's take our original equation again. So here's another approach. Right, we could take this problem and we could set up, we could say, okay, let's set it equal to 0, find the zeros, turn them into factors. So if we take the equation x squared plus 34x plus 21 equals 0, well, that's just a quadratic formula problem, right? So we end up with x equals negative b. You know the song, right? It's up there too. You got to remember the formula. So x equals negative b plus or minus the square root b squared minus 4ac, right? A is 8, b is 34, c is 21. All divided by...
Howdy there, Roy.
Hey, Justin Marcus. Great, thank you. Divided by 2a, right? So now we have to just simplify that. So somebody real quick, what's 34 squared? I don't know that one. What is that? Quick, you got a calculator?
1,156.
It is?
Sure.
No, it's not.
It's not?
Is it really?
I don't know.
No,
What happens if it is?
it's not.
What do I win?
You win fabulous gifts and prizes. Actually, that might be right.
Good job, Cassidy.
Yeah. How'd you get that?
I did it.
Oh, you just did it. Good.
Yeah.
Oh, that was good. No, you're right. You got it. Good. So, very nice. Fabulous gifts and prizes coming your way.
Great.
So that's going to give me what I get in here then. So I get 1,156 minus, what's this guy? Now this one we can do. 8 times 21 is 168 times 4 is going to be 4, it's going to be 640, it's going to be 672, is that right? Check me. 672.
What?
Check
What did you
Cassidy.
ask?
Cassidy knows.
672.
Oh, nice, okay.
Yeah.
Then he started doing something different. I'm like, oh, no.
Okay, so then what's that give us? So if we, what did I just do? Oh my gosh, what's going on here? Mayhem is breaking news here. Okay, so then we end up with,
I'm not that smart.
so if I subtract these, what do I get? I get 1156 minus 672 is 484, okay? Which is gonna be 20, no, what is that? I don't know what that is, let's square root that. 22. So all this stuff just becomes 22. Okay, so how would this have worked? Then we get two answers. If we take the plus, we get x equals negative 34 plus 22 is negative 12, is that right? 16ths, which reduces to negative 3/4. Well, if x equals negative 3/4, that's the same as, isn't it, the factor right there. X minus negative 3/4 is x plus 3/4. See what I'm saying? So that gets us right to there. What do you think we're going to get for the other one? Well, I mean, it's going to be, if we take the minus, I would get negative 34 minus 22 over 16 is negative 56 over 16, which reduces to negative 7/2. Well, x minus 7/2, x minus negative 7/2 is x plus 7/2, right? And now I would just go bottoms up and I'm done, right? So Brooke, you're right. You actually could use the quadratic formula on that. If you use the quadratic formula and you get the zeros, turn them into factors and go bottoms up, that always works too. Okay. How about this? Okay, this is super easy, right? Well, how do we factor two-term factors? What do we do? Difference of squares. We did a bunch of them. We did difference of squares, difference of cubes, sum of cubes. On the test, I'm only going to give you difference of squares. Right? So we know a squared minus b squared factors into what? Come on now. A plus b, a minus b. Good. So then if we've got x squared minus 121, isn't that just x squared minus, not equals, x squared minus 11 squared. So x is a, 11 is b. There it is, right? Okay. So that's no big deal.
Oh, hold up.
Okay, I'm taping this. I'll put it up today. I'll put up a PDF of notes too. How's that? Okay, solve the equation. Well, this is already done. I mean, all you have to do is set the, it's already factored, right?
Yes.
it's in standard form, set equal to 0 when it's factored, so all we've got to do is use the zero product property. So what's that mean? Everett, what's that mean?
Set them both to 0.
Set them both to 0. So if I set 7x minus 6 equals 0, what's the result?
7x equals 6.
So then x equals,
6 divided by 7.
very good. Okay, and then if I did this one, we'll just jump right to the answer. What's x going to be if I add 9 to the other side, divide by 4? Maria, what are we going to get? What if I solve that one? But what's the 0 of that one? If I set it equal to 0 and solve. 9. I'd add the 9 to the other side, and then what? Okay, but no, hang on. If I have 4x minus 9 equals 0, so what am I going to do? 9 over 4, there you go.
But don't you have to multiply those together?
No, all it wants you to do is solve the equation, so those are my solutions. Right? Either x equals 6/7, that's going to make this 0, or x equals 9/4, right? How would I check? Plug them in. Okay? You're being, I think you're confused by the fact here maybe that this is easier. I mean, they've done the hard work. They already factored it for you. So now you just set the factors equal to 0 and solve each one. Okay, how about this? Factor it and set the factors equal to 0, right? Or, what else could you do if you really wanted to? Always. It's a quadratic formula, a quadratic equation in standard form. Quadratic formula, but it'd be way easier to just factor it, right? Okay, should we skip that one?
Yeah.
Okay, so on these, now I didn't bother to change the wording. Some of these questions when I wrote this final for you guys to match Blue Mountains, I didn't feel like changing all the words and everything. So it says if you get imaginary numbers, write your answers as complex numbers in standard form. Okay, there are no imaginary numbers. What this really should say is find all real solutions. You're not going to get any I's on the test, right? It's all going to be real answers. Well, how do we solve this one? This is pretty straightforward. Add 9, because I've got a single x there I can point to so I can isolate it. So what's x? Well, okay, but plus or minus.
Wait,
Right.
what?
Because when you square root both sides, you got to put a plus or minus in, right?
Square root of 9 is, oh, it is 3.
See what I'm saying? So in Moodle, you would put the answers in as 3, -3, right? Okay, don't forget that plus or minus when you square root both sides, right? Okay. How about this, Manuel? What are we gonna do with this one? It's very similar. I mean, it's. Say it again. Does it look like a? So is 7x something square? No. So what do we got to factor it and set the factors equal to 0. That's always our strategy. How do we factor this? Take out an x. Yeah, these are easy. When they're two terms, they're simple. Either it's going to be a pattern or you're just going to factor out a greatest common factor, but that's all you can do. There's nothing hard to do when there's two terms. So I can undistribute an x, leaving me with what? So what are my zeros? If I set that one equal to 0 and solve, it's just 0. Done. How about this one? There we go. Okay. Good. Okay, what about this one? What would I do? Divide by -2.
Yeah.
Good. And square root.
Yeah.
So what do we get?
9.
Or
-9.
-9. Okay, so 9, -9, or vice versa. Okay. Okay, so this one, there's only one question on here like this. This is just the completing the square stuff, right? If we were going to create a perfect square trinomial with this, right? What's the rule? What do I do? What do I have to do? So I would just get C would have to equal what? do we do that? Remember what the trick is? If I want to make a perfect square trinomial, I always do. Remember that? What did we do? Right, we said it's going to factor into what goes here. Yeah, so that's going to be a minus 14 squared, right?
Yeah.
So we always do half of b, and then to get up here, we're just going to square that, right? So up here, we're just going to get negative 14 squared. So what's c going to equal then? What's negative 14 squared? You know? 196, right? Okay. Does that make sense?
No.
Okay. So all you're going to do, that's the rule. It's really simple. If I start with x squared plus bx and I want to create a perfect square trinomial, the number I add is always half of b squared. And then that's going to give me, look what would happen. That would give me the result. I would get the trinomial x squared minus 28x plus 196. And what does that factor into? Well, it's a perfect square. What is it again? X minus 14 squared.
Wait,
You don't even have to know that second part of it. Say it again.
Is that the answer?
So the answer, all they want here is this. They just want to know what's C. So our answer would just be, they just want to know what would you put there? 196. The reason we would do it, like that we did it earlier in the year when we completed the square, was so we could, right, we could get that. We could get a perfect square out of it. Okay? Alrighty. How about this one? So what are we going to do on this one? We already did one, quadratic formula. We already did one like this, so I'm going to skip it, right? But this is just like, it's just like what we did down there, right? We ended up getting 2 answers by using the quadratic formula, right? So I won't do another one. You can, if you want to come in and get some help on that, that's fine. But I think you're okay with that. Okay, what about that?
Factor.
Okay, factor. What are the magic numbers?
50.
Are you sure?
It's the other way around.
Are there magic numbers?
No.
No, there aren't. So what do we have to do? Quadratic formula. Okay, I am going to do this one though, because this one you'll see is just a little bit different than the last one. So quadratic formula, what are the values of a, b, and c? 1 and okay. So then the quadratic formula tells us that x equals negative 10 plus or minus the square root of 10 squared, right? So that's going to be 100 minus, what's 4 times a times c? 28. All divided by 2 times 1 is 2. Well, that's just negative 10 plus or minus the square root of what, 72? Over 2. So we have to, probably the hardest part of this whole thing here, it's not very hard, is we just have to reduce that, or simplify that radical. So what's the biggest perfect square factor of 72? What do? We just go down the list, right? We start with, 72 is not a perfect square, so we start with half of it. Vanessa, what's half of 72? Well, you don't have to answer that. What's the biggest perfect square factor of 72, do you think? Hard to see that list, it's pretty dark in here. What is it? 6 squared, so 36, right? We could break 72 up into square root of 36 times square root of 2. We agree? And then we'd circle this one, because what's the square root of 36? Okay? Right, does that make sense? Okay. And then we end up with what? So that's going to give us So that's gonna give us 6 radical 2, we said, right? All over 2, but let's do that differently. Instead of writing it as one big denominator, let's just go ahead and split that denominator into 2 parts so we can reduce each fraction, right? Sometimes one fraction will reduce and the other one won't, right? In this case, they both do, so what do we get? Plus or minus?
3/1.
Yeah, 3/1 would just give us a 3. Radical 2. So those are our 2 answers. Now in Moodle, how do we have to put those in? Separate them, yeah. -5 plus, 3 radical 2, comma, -5 minus 3 radical 2. Okay, good? Good? Okay, so this brings us up to stuff we're already doing, right? So what about this? Bailey, what do we do with these? If I'm going to simplify a radical expression like this, what do we always have to do when we're simplifying? We're adding rational expressions, or we're dividing or multiplying or anything like that, or just simplifying. What do we always have to do? Remember? What do we have to do to the bottom? Say it again. Well, I mean, you might have been thinking the right, just you said the wrong word. Yeah, we're going to factor it. We've got to break it into factors. Okay, so then what do we get? On the top, it's already factored. On the bottom, what does that factor into? What are my magic numbers? It would have been, common denominator would have been, like if we were adding or subtracting or something, you're right. We would have had to create a common denominator from the factors, and we'll do one like that in a second.
7 and 8.
Okay, so 7 and 8. Good, okay. So then how do we simplify this? What good did that do us? We get some cancellation, don't we? Yeah, so we get the x plus 7 factors cancel. And then what are we left with on top?
X.
No.
What? 0?
Well, not 0. 1, right, good. We just get a 1. Okay. So we get a 1 on top and on the bottom, x plus 8. And that's our answer. How would we check it? By plugging in, you mean?
Number.
Plug in a number. Yeah, plug in a number, get the result, plug in the same number here and see if you get the same result. Okay? Good. All right. Okay, so let's do a subtraction problem then with rational functions. We've got fractions, big fractions involving variables. So this is where we do need a common denominator, right? But we always, this is where, like I said, you're working on this right now. This is probably, in my opinion, I don't know, maybe one of the hardest problems. I don't think it's not super hard, but it's one of the hardest problems on the test. Whenever you add and subtract rational functions, rational expressions, you always have to get a common denominator, right? So we got to factor first. We get 8 over x minus 9 over, what's the bottom factor into?
Squares.
X times what? Plus 1, good. Right, how do we know? If I undistributed x, then to see what's left over, I just divide each of these by x, right? X squared over x is x, x over x is 1, right? So there's, I've got everything factored. What's my LCD going to be then? X times, what is it? X plus 1, right? How come? Well, the x takes care of that and that, right? And the x plus 1 takes care of that. We have to find the smallest product of factors that's going to include an x as a factor. Okay, that's what this fraction needs. This fraction needs it to include an x and an x plus 1. Well, that does the job, doesn't it? Right. So then when we're adding or subtracting fractions, we have to get a common denominator, right? So what do I have to multiply? Got this fraction up here. I need to get this for a common denominator. So what do I have to multiply top and bottom by here to get that denominator?
X plus one.
X plus 1, good. But I gotta do the same thing to the top and the bottom, right? And so then I end up with 8 times x plus 1 minus 9, right? That's what we get in the numerators, divided by my common denominator of x times x plus 1. Because isn't that what we do? When we add or subtract fractions, we get a common denominator and then just add or subtract the numerators, right? And so if I simplify this, Nick, what am I going to get if I simplify this? Back, Nick, what do you think? If I distribute the 8 and combine like terms, what do we get? 8x. So I get a plus 8 minus 9. So what's that going to be? Minus 1, good. Over my common denominator, x times x plus 1.
Why don't those just cancel?
Why don't what just cancel? These? These?
No, X in the thing, in the answer, X plus 1 over X plus 1.
Oh, right here?
Yeah.
Okay, because you can only cancel factors, right? This is not a factor because it's not being multiplied by everything. It's something is being subtracted from it. It'd be like saying this. It'd be like saying if I have 3 minus, let's do 3 plus 2 over 3. Well, let's just cancel the 3's, right? And I get 2 for an answer. That's not the answer, right? The answer is 5/3. See, I can't do that. Now, if I had 3 times 2 over 3, then I could. And that works. The answer is 2, which is the same thing as 6 over 3, right? You can only cancel things that are being multiplied, right? Not things that are being added or subtracted. Okay, when are we out of here? 25? Okay. So let's just, how about if we just go through, this is probably good. I mean, there's a lot. Let's just go through this today. The practice final is up. I'm going to be gone tomorrow. You guys, I have a work day set up for you tomorrow. You can work on going through the practice final. You can do homework. We'll wrap this up on Friday, and then you have all next week to just take the final, right? And then when you're done, you're done, okay? That's the last thing we're doing. All right, so what about this? This is a good one to finish on, though, because there's a few things going on here. Yes, sir?
How long is the final?
20, this is it, 28 questions. Okay. So it might take you 2 days to do. I'll put it up, if you guys want to do the final,
Yeah.
I'll put, but you only get that one retake is the thing. So if you go through it at home and you feel comfortable with it, I'll make it available tomorrow.
Yeah.
And if you want to do it, that's fine, okay? All right, so what about this? If I've got a fraction divided by a fraction, what do? We have to follow order of operations, first of all. I want to link this back to order of operations. Everything goes back to that order of operations tree that we talked about earlier in the year. So order of operations, remember, tells us that if we're simplifying, we have to do everything in parentheses first. Do you see parentheses there? Okay, are there any invisible or implied parentheses there? Now think that P really doesn't, we say parentheses, but it just means anything that's grouped. So grouping symbols or just implied grouping symbols. Do you see any stuff there that's grouped together? Say it again. What about the fractions? Okay, you're right. So by the fractions, what do you mean by that? Okay. And I've got 2 different fractions, don't I? I've got a fraction based on a fraction divided by a fraction, right? So anytime you divide stuff, everything in the numerator is grouped, right? It's all over a common division bar, right? So that's always the case. The entire numerator is grouped and the entire denominator is grouped. And so that first step really means I've got to simplify the top fraction and simplify the bottom fraction. What I always talk to my classes about when we're doing that is you're going to turn the top into one big fraction. Turn the bottom into one big fraction, and then what do? You divide a fraction by a fraction. Yeah, flip and multiply, right? So we've got to take this top one and add those up and turn it into one fraction. Take the bottom one, add those up, turn it into one fraction, and then flip and multiply. Okay, so let's deal with the top. 1 is the same as 1 over 1, right? What's my common denominator for that top fraction? Not 1. What's the smallest thing that both 1 and x divide into? X, right? I mean, if this were a 3 on the bottom, you guys would tell me it's 3, right? So it's just an x instead. The common denominator is x. What do I have to multiply top and bottom by of this first fraction to get a common denominator? But I need an x on the bottom, agreed? So I gotta multiply by x, yeah. So I'll just multiply by x, and then that's just the top fraction, right? We'll deal with the bottom one in a second. But for the top one, then that gives us a common denominator of x, and then I just have to do x minus 4, right? X over x minus 4 over x is x minus 4 over x. So first part's done. The top fraction, we turned the numerator into one big fraction. Okay, what about the denominator? In the denominator, we've got x over 1 plus 1 over 5. What do I need to get on the bottom of both fractions to add them up? 5. So I'm going to multiply this guy by 5 over 5, right? And then that gives me on the bottom 5x plus 1 over my common denominator, 5, right? Everybody agree? And so I've got one big fraction over one big fraction. And so now I can just flip and multiply, right? Top one stays the same, but whichever fraction's on the bottom gets flipped, and I multiply by it. So x minus 4 over x times 5 over 5x plus 1. So if I multiply that out, what do I get? If I distribute the 5, what do I get? Yeah, good. 5x minus 20. If I multiply the x through, well, 5x squared, good, plus x, right? If I take the x and just distribute it to each part. All right. I think that's good for today. I gotta take a roll.